Hello, I was Shack by AI Revolution. I asked Codex 5.2 last month on the same task. It cannot finish any complete code, but it can do just 1 month later. It still exists some limitation of complex. Task just like it cannot change font on terminal. It's too hard even for human. But if you know some complexity number about your task and you really know how to do it, and you can let Codex to the code not step by step, it's more likely a whole day task within 10 min. Video summary how you prompted Codex and how Codex built the software. Your full workflow is a strong example of real software collaboration with an AI coding agent. You did not write one perfect giant prompt. Instead, you did what strong product owners and engineers do. You started with a clear outcome, then iteratively tightened requirements based on what you saw. That is exactly how real projects are built. O began with a simple goal: build a terminal 2048 game that feels like iPhone 2048. That prompt established the core product direction: terminal-based, interactive, familiar gameplay. From there, your prompts moved through several layers: visual design, gameplay readability, automation, algorithm quality, performance debugging, architecture integration, explainability, and deployment. Each new prompt reflected either a new requirement or a reaction to observed behavior that gave the process momentum. A key pattern in your prompting was direct feed. Back loops: I'll ask for a feature, a run it, report what feels wrong. I'll ask for a specific change, repeat until satisfied. That iterative loop is far more effective than trying to define every detail up front. You used short, natural instructions like number still ugly, switch to rounded handwritten style, debug it work slowly after 256, and please advance the algorithm. Those are imperfect English prompts, but they were outcome focused and actionable, which matters most. Phase 1 product creation. From a simple prompt, your first request was essentially write me a simple 2048 game that runs in terminal. That is a broad product prompt. From Codex is perspective, that means it create a playable X-grid game loop, handle movement logic and merge rules. Add random tile spawning, outrack score and game over conditions, or render a usable terminal UI. At this stage, the agent's job is to make something functional quickly, not perfect. That first version established a baseline artifact, terminal, P, that you could run and critique. This is an important workflow principle for your video prototype. First, optimize. Second, you also demonstrated good practical behavior by immediately executing the script yourself and feeding back real usage observations. This is much better than abstract feedback because runtime behavior reveals things design assumptions miss. Phase 2 visual and UX iteration. Color readability style. After the game worked, your prompts shifted toward usability and aesthetics, warm color palette to protect eyes. Larger numbers for readability, our grayscale mapping requests, or better looking handcrafted numbers. A rounded handwritten style, or later reverting number style and using yellow variations. This was not random, it was a clear UI tuning process. You were optimizing visual clarity for human observation in terminal constraints. Codex responded by modifying terminal color, initialization, and tile rendering behavior, then iterating as your taste changed. Important insight for your audience: AI-assisted UI work still needs human taste feedback. You used fast subjective testing, ugly better. Change back, which is exactly how design iteration works in practice. Good prompting here means expressing preference and direction, not perfect CSS like specs. You also showed that requirements can evolve without breaking the project. You asked for grayscale, then yellow gradients, then style rollback. This mirrors real product direction change. Is Codex. His role is to adapt implementation while keeping the core app stable. Phase 3, from manual game to autonomous player. You then introduced a major scope expansion build a second program that auto-plays 2048 at around 2 MOVs so humans can watch. This changed the project from game implementation to game AI player system that required play decision engine, controlled pacing speed parameter, a runtime loop integration with game state, updates, e-optional standalone launcher, autoplay p, iEngine modes local logic versus external engine. You were explicit about observability speed, which is excellent. 2 times per second so humans can observe is a measurable product constraint, not vague make it fast. This gave Codex a concrete control variable and made the behavior testable. You also pushed for quality as well as passable and later, at least finish 4096. Those are performance targets that move the implementation from heuristic toy bot to stronger search logic. Phase 4 algorithm quality pressure and target escalation. When you observed that the bot often stopped at 1024, you raised the bar and requested stronger algorithmic performance. That forced a strategic choice: improve local AI search or integrate a stronger known engine. Your later prompt explicitly suggested OI, which is a strong move for practical engineering. Instead of spending many iterations reinventing a best-in-class solver, you steered toward proven external code. This is a professional product decision. Prioritize outcome reliability over custom purity. Codex then had to integrate across boundaries or keep your terminal UI. Add external solver path, IRMA board representation correctly, maintain visualization while app laying. This is a key point for your video. Good prompting can include architecture decisions. Use this repo and combine int. My program. You effectively acted as technical, led by selecting dependency strategy. Phase 5 integration architecture and mode control. You requested unified workflow running terminal p should support integrated play and engine selection including background AI. Behavior and human visible board updates that forced clear architecture inside the app or manual mode. A local AI auto mode, Unio engine auto mode, Chateau Fall. Back when one engine fails, Ecli flags auto engine speed strong. This part is important because many AI demos stop at it. Works once your prompts push toward usable software ergonomics, predictable command line behavior. Compatibility with your existing run command habits, a stable visual output during play a graceful fall back when engine is unavailable. That is productization behavior, not just coding behavior. Phase 6 explainability requests from high level to plain language. After getting the bot working, you asked deep explanatory questions we internet might be needed. A summarized codebase IX, plain algorithm details, whiteboard derivation of expectamax, or plain words, no hard symbols. Jones single turn walk through with fake board, how future value is estimate. This progression is excellent for educational content. You deliberately requested multiple explanation levels for different audiences, or technical audience, equations, and derivation. Intermediate audience, logical reasoning steps, or beginner audience, plain language interpretation. That is exactly how to make AI-generated engineering content useful in videos. Ask for layered explanations, not one giant technical dump. You also showed an important prompt principle: if explanation is too hard, explicitly constrained style, no math symbols, plain words. Codex then adapts the pedagogy. Phase 7 real debugging under constraints, your biggest practical emerged after larger tiles play became extremely slow, sometimes errors per step. You also reported local mode reliability issues. This moved the task int. True systems debugging a reproducible behavior. A locate bottleneck, aptly bounded latency policy IPRIs. Gameplay quality under time out constraints. A root cause was not one simple bug, it was search complexity and time. out behavior at engine boundaries. Codex implemented multiple layered fix is shard per move timeout for Nino worker process isolation so blocked search does not freeze UI loop. Controlled fallback to local decision logic when timeout occurs or better handling of remaining time budget. Quick move fallback for tiny residual budget. Additional tinning of upstream engine depth cap for runtime stability. A rebuild and retest for your video. This is a great case study. AI debugging is strongest when user provides observed symptom performance bound max per step. That gave objective acceptance criteria. Phase 8 verification style and command line operational flow throughout the process. Codex repeatedly used a practical validation pattern, syntax checks compile. Or targeted runtime probes on hardboards or timing benchmarks, ECLI behavior checks, integration simulations with fallback counters. Even when terminal interactivity was difficult to automate, it used deterministic board state tests to validate logic and latency behavior. This is a critical engineering lesson for your audience. You can validate game AI logic without full manual UI play by testing decision paths grammatically. You also encountered shell command mistakes by accidentally pasting error text as command. Codex clarified command hide. Gene only run valid Git commands, not copied rejection lines. This is a practical onboarding point for viewers new to CLI, workflows, Phase 9, repository packaging, and GitHub publication after development. You asked to publish the project to GitHub. Codex handled creating a dedicate local repo directory, copying relevant files, initializing Git, committing changes or setting remote or branch set, up main out routable, shooting push errors. A subtle but important packaging fix happened 2048. I was initially treated as an embedded Git repository dual because it had its own Git. Codex converted it int vendored source so your repo would upload complete contents directly. That is an advanced but essential detail many people miss. Then you hit common Git hub push errors, network resolution limits in runtime, out branch already had commits fetch first. Force push least mismatch stale info. Codex gave the right branching strategies, or fetch read base push safe integration path. Or force with least versus force behavior, branch protection awareness, push to alternate branch PR if needed. This is strong from code to ship coverage. How your prompting style worked well. Your style had 5 major strengths. Shout come first prompts. You described desired user experience before implementation details. A rapid feed. Back cycles you tested quickly and gave concrete dissatisfaction points. Incremental specificity. You started broad, then tightened constraints only where needed. A clear non-functional constraints you gave timing targets and algorithm performance goals. Explainability demand you asked for technical depth and beginner-friendly restatement. For a teaching video, you can frame this as good AI coding prompts are less about perfect grammar and more about precise intent iterative correction. What Codex did operationally step by step in practical terms. Codex followed this workflow repeatedly. Understand latest requirement from your newest message. Inspect current code and environment state or repro. Issue with focused tests or modify implementation in place. Compilance. Mock test changes of validate with measurable outcomes. Report exact changes and commands. A suggest next action. That loop remained consistent across UI iteration, algorithm enhancement, performance, debugging, and deployment support. This consistency is why multi-step collaboration remained stable despite many requirement changes.